We're looking at in behavior models, and so we're going to also use these for the asymptotes. So when we do in behavior models, they're looking at what happens as the limit as x approaches positive or negative infinity. This is what we use in behavior for. So in behavior models, if we have the degrees are the same, say 3x squared over 2x squared, then you get an in behavior of 3 over 2. That's the number it's going to approach as it goes off either direction. So our asymptote is y equals 3 over 2. If the larger degree is in the denominator, say 3x over 2x squared, then your end behavior is going to be 3 over 2x. So as this guy gets larger and larger and larger, this one gets larger and larger and larger, you're going to get, this guy goes off to 0, so you can get a value of y equals 0. Because your denominator is getting larger and larger, which is making your fraction smaller and smaller. So off to 0 he goes. And then the last one is the numerator is larger, so say 3x squared over 2x. This is going to give you 3x over 2. This one has no horizontal asymptote because the denominator is still larger. So what happens is as this number gets bigger and bigger and bigger, the 2 has very little saying what's happening to it. So what you're going to have instead is you're going to have an oblique asymptote. Now, we'll talk about those later. Now, but the question still is, well, what happens? What happens here is that when you have this, where the x is, the power is larger on top, is that your limits are going to go off to infinity, one direction or the other. And again, we'll look at another problem here in a few minutes. So let's look at this one here. In behavior model, anytime they start talking about, if they say in behavior, they're talking about limits at that point. If they want the model, then at that point, they're just, how am I going to get to that in behavior? But always keep in mind you're looking at the first terms, because we're talking about, again, we're talking about the limit as x approaches positive or negative infinity. So what we have here is f of x is going to equal 3x squared over 4x squared, and the x squares cancel out. So you're going to get a horizontal asymptote of 3/4. So as x approaches positive or negative infinity, this whole thing is going to go off to 3/4. So what about this one? Let's talk about this one. Again, you're looking at the front end of this. So you have x squared over x, which is going to reduce down to x. No horizontal asymptote, no way of getting rid of this x, but we all know what lines look like. If I put a line in there, this thing is going to go off this way. So let's talk limits. As the limit as x approaches infinity of f of x is going to follow this line, which means my y value has no bound. It's going to go off to infinity. And the limit as x approaches negative infinity of f of x, now we're going this way. And as my x's get smaller and smaller and smaller, so basically do my y values, so this guy is going off to negative infinity. Remember, the larger the negative value, the smaller the number. But this is what happens when we have something like this left over. Is that this is what's called an oblique or slant asymptote. So next problem. Since there is no horizontal asymptote, what is the oblique asymptote? Now, hopefully you guys remember how to do synthetic division. You take the x minus 3, set it equal to 0, so x is equal to 3. That's what you're dividing by. And then you take your coefficients. So 1, 1, 9. Bring down the 1. 3 times 1 is 3. Add down, we get 4. Multiply 3 times 4, we get 12. Add down again, we get 21. But this is the remainder. We don't care about the remainder. The constant and the x. So y equals x plus 4. So on the last page, we graphed this going through the 0, but when it comes to limits, it's not going to make a difference. If I'm up here, guess what? The graph is still doing the same thing. As I go off to positive infinity, my y values go off to positive infinity. As I go off to negative infinity, my y values go to negative infinity. So this 4 is not going to make the difference, so we really don't have to go this far. We can just reduce this. Okay, so this one here, this is a release question that I decided to put on there for you. Let me make some notes on here. This is an open circle. This is an open circle. This is a closed circle. This is an open circle. And this is a closed circle. And they're just asking you to identify which statement is true. So we go through this. The limit of f of x as x approaches negative 4 is equal to 3. Well, here's negative 4. If I come down this way, I'm getting to negative 1. But if I go this way, I'm going to 5. Well, 5 does not equal negative 1. So this one is false. But they're asking for the true ones. So we get to throw out all of the ones. Then we look at statement number 2. F at negative 4 is 3. Negative 4, 1, 2, 3. There it is, F of 4. This one is true. So I'm going with my answer is B, but please, please, please do get in the habit of checking this one, even though there's no way B and C can be true. This one here, the limit of f of x as x approaches 4 equals 5. Well, if I come this way, I'm going to get to 1, 2, 3. And if I come this way, I'm going to get to 3. So this one is false as well. Now, if they had asked for f of 4, then you would have gotten 5. So this is the only answer that could possibly be. Do get in the habit of eliminating answers, going, well, one's not true, so anything with a 1 in it's out. Okay, last question. This was a release question, AP release question. Sorry, lost my train of thought. This was a release question, and it was actually thrown out because so many students missed the question, including students who are getting 5s on the test. And this was a multiple choice, did not have the graph, nor could they use calculators. So I want to point out that you guys have the graph, so you can look at this going, well, as x approaches infinity, this thing is going off to negative 1. And this way, so arrow, and going this way, we can see that this guy is a little bit more than 2. It's greater than 2. How much more greater? We don't know. So let's look at this, why they have 2 separate ones when they look like they should have the same. Because a lot of people will look at horizontal asymptotes. And so they will consider that they would have the same. I put x or negative x. These are going to have the same powers. But here's where, unfortunately, the thinking goes bad. This one here, 5 plus 2 to the x over 3 minus 2 to the x, as long as these values are positive, this guy is going to take control. So it'll be 2 to the x over negative 2 to the x, which is going to give us negative 1, what we got over here. It's this one that threw people off. Keep in mind, a negative exponent puts it into the denominator. So this is 5 plus 1 over 2 to the x over 3 minus 1 over 2 to the x. So our problem that happened here is that now my x is in the denominator, and this fraction, as this number gets larger and larger and larger, the whole fraction gets smaller and smaller and smaller. So this guy is going off to 0, and this guy is going off to 0, which leaves us this guy 5 over 3, which is just a little bit less than 2. Oh, I said it's going to be greater than 2. It's going to be less than 2. So the answer on this one is 5/3, where the answer on this one was -1. And this is where the unfortunate confusion went. Okay, so let me try this one again. You know that you don't have to do the book work anymore, that I'm assigning other worksheets. So good luck on these.